Hi, Anatomy. I hope you guys are all doing well. I miss everybody so much. It's crazy. It's nuts to be ending the year like this. So, I don't know why I put that up there just now. So I know that the immune system is extremely confusing. So hopefully this video is going to help you guys out a little bit. So, there are really like two parts to the immune system. There's the innate immune system. And the innate immune system is the immune system that you are born with. So a newborn baby has an innate immune system. And the defenses that exist in the innate immune system are what we call non-specific defenses, or the non-specific response. Non-specific because they're tools that we have to really fight off anything. It's not specific for one particular virus like COVID. So, our skin is an example of our innate immune system, or a non-specific response, because we all have skin to keep out foreign invaders. We have mucous membranes. We have, nose hairs. We have tears. We have stomach acid that can kill foreign invaders. We also have certain white blood cells that are non-specific. These are macrophages. Macro because they're large, and phage because they are a cell. These are your eaters. They're literally eating and destroying foreign invaders. And another way to say a foreign invader is a pathogen. So all living organisms are born with these non-specific defenses. Another thing that you guys probably read about was the inflammatory response, which is also non-specific. And this is an immune response. So like if you cut yourself with a dirty nail or something like that, it's going to get red, it's going to get swollen, it's going to pus, and obviously it's going to bleed. And that's all part of the inflammatory response. Inflammation is good because it's your body trying to fight off and protect itself. So a little inflammation is good, but obviously if it's causing pain, then you want to take some kind of medication to reduce the inflammation so that you can feel better, because sometimes the symptoms are worse, obviously, than, just allowing the body to do its thing. So with the inflammatory response, if you cut yourself with a nail, there are cells called mast cells, and these cells produce a chemical called histamine. And what histamine does is it actually causes the blood vessels to dilate, to get bigger. And the reason the blood vessels, you want them to get bigger, is because that's going to increase the blood flow to that area. And in the blood are going to be white blood cells like macrophages, there to come and eat and destroy the foreign invader before it gets into the bloodstream and then to other tissues to infect. So the histamine, that chemical, which dilates, it's called vasodilation, which dilates the blood vessels, is the reason why it's red, because there's an increased amount of blood flow to the area. You might notice that, like, if you're working out, that area is going to get red and it's going to throb because there's going to be an even more increased amount of blood flow. It also makes you itch. So sometimes the inflamed area can be itchy, and that's because histamines can cause itching. They're also responsible for the itching that you get with allergies, same kind of response. So you would take an antihistamine like Benadryl or something like that to block the histamine production. And I know you're probably like, well, wait a minute, you're blocking what your immune system is doing. Isn't that, not good? But like I said, sometimes with the symptoms, they're hard to tolerate, so you need to do what's good for you. So this is all the non-specific immunity. There's also something called passive immunity. This is what the mother passes on to their baby during nursing and breastfeeding. That's why they say, nursing is really important during the first couple of weeks if you can do it, because you're actually passing antibodies to your baby that can help them fight. But that's one of the reasons also why, like, if you have a baby now, you really can't have any kind of visitors, because if the baby got COVID, it could be really dangerous because they don't have any kind of immune system yet. So our specific immune response is a little bit more complicated. So this is the part of our immune system that is responsible for fighting specific pathogens. And it's also the reason why you can't get the same disease twice, which is not always true, but for the most part. So pathogens are foreign invaders, a virus, a bacteria, a fungus, and all cells, whether it's a virus, which is actually not living, or bacteria, which is living, they have protein markers. They have ID tags, which basically tells your body that, hey, this thing doesn't belong. And that ID tag is called an antigen. So if you think of yourself in the school as the pathogen, the ID that you guys had to wear, don't you miss wearing those? Wouldn't you just go back? You would wear them all the time just to be in school. I mean, I know that's how I feel. But anyways, so that ID that you have around your neck is your antigen. That tells everybody who you are. So your body is really responding to these foreign antigens, these foreign ID tags on the pathogen. Okay, so essentially what happens first is when something gets past your first and second line of defense, and you have a virus that's, getting into the body, the macrophages, the eaters, they're going to actually kind of come and try and chop up that virus and present a tiny piece of it on its surface. And that is basically going to signal the following. So, I'm sorry, it's kind of backwards here. Oh no. Okay, so at the top, if you guys see, it says helper T cells. I don't know how to flip that. Oh, I'd have to flip the camera. Okay, well, we're just going to do it like this. Helper T cells. So T cells are produced in the thymus. That's a gland that kind of sits over your heart. And the helper T cells are responsible for two things. The first is humoral immunity, which you can kind of read backwards, or the humoral response. And the second is the cell-mediated response. So humoral, this is referring to the humors of the body. So this is basically in the fluid of the body. So the blood, traveling in the blood. So any kind of foreign invader traveling in the bloodstream. Cell-mediated, this is the immune response that's going to be responsible for destroying cells in your body that have already been infected by some kind of foreign virus, maybe like COVID. So we're going to start over with the humoral response. So the helper T cells will sort of like sense that antigen that the macrophage has presented, and it will stimulate the production of B cells. B cells are specific immune cells that are made in the bone marrow. That's why they're called B cells. And those B cells will differentiate into antibodies. I always remember B cells differentiate into antibodies. Now, you've all heard of antibodies because you've probably been like, oh, I want to get an antibody test for COVID to see if I've ever had it. Well, antibodies, what they do is they bind to the antigens that are on the surface of the pathogen and disarm it, disable it. So it would be like police officers surrounding you and grabbing you until you can't move anywhere. And that will then allow other macrophages to kind of come and say, oh, hey, I got this pathogen, don't worry, and eat it and destroy it, because it can no longer move through the body because the antibodies are kind of like disabling it and disarming it. So antibodies are specific. They're proteins that are specific for the antigens that they're going to act upon. Antibodies will eventually become, as you can see at the bottom, memory cells. So they hang around in your body forever. So that if you ever get that virus again, you already have the tools to fight it off, the antibodies. So when you're getting your antibody test for COVID, which I got mine and it was negative, I was actually kind of hoping that it would be positive so that I knew I was immune to the disease. But anyways, if you're doing an antibody test, you're testing to see if you have had that disease because you would have antibodies for it. So that takes care of any kind of virus that's floating around in the humors or in the fluid or the blood. Now, let's say that COVID has infected your cell, and these are the lung cells, right? So we need to destroy those infected cells because you don't want them making baby viruses and then the virus spreading. So helper T cells will also stimulate the production of what are called killer T cells. And killer T cells literally do exactly what they say they do. They kill, they destroy. They will kill your own infected cells. And you have so many cells that, it's okay to lose some. We don't want those infected cells staying around. And they also become memory cells, so that if you ever get that disease, you already have the antibodies to take care of the viruses in the humors or the fluid of the body, and then you have the killer T cells to take care of any infected cells by the virus. Okay, so the idea is that if you have had corona, then you can't get it again because you already have the antibodies and killer T cells to fight it off. But the issue is if it mutates and becomes a different kind of virus with different antigens, then it's going to be able to infect the body and you're going to launch a new attack. So that's the whole debate is, can you get it twice? Vaccines really are just weakened versions of or dead versions of the virus. And it's going to stimulate that same immune response so that you produce antibodies and killer T cells. And so if you ever get that virus, you already have those tools to fight it off. So you fight it off so quick before it can actually infect the cells and make you sick. The reason why vaccines take so long to make is because they need to be tested. They need to be tested on animals and they need to be tested in human trials to make sure that there are no adverse effects and side effects. Because, would you take a vaccine that hasn't been fully tested? I know I wouldn't. So it takes a while, and that's why they're saying, it could take a year and a half for a vaccine to become available, no matter how hard they try to rush it. So yeah, we've got the helper cells that are going to be responsible for the humoral and cell-mediated immunity. These are both specific responses, and I hope that helps. If you guys stayed on for this long, I appreciate it. You guys are going to finish your notes. It's basically just on the rest of what you've learned about before, like bacteria and how diseases spread. And then next week, you guys are going to be creating an immune system disease slide. There's a lot of really interesting autoimmune diseases. Autoimmune diseases are on the rise. Who knows why? But there's a lot of different ones that you might be interested in. And then we're going to present that in a Google Meet on our final class period, which I'm looking at my notes. That's going to be June 11th. Now we do have school June 12th and 15th, but it's just going to be very casual, submit any missing work. Okay, guys, I miss you. I hope you enjoyed this, and have a good day.